Right. Good afternoon, everybody. What we're looking at today is a statistic question, and I'll be focusing on the cumulative frequency curve. Well, this question definitely comes from the January 22 CXC paper 2, and it's question 5. So stay tuned. We'll be right back after these messages. All right, so here's a question that we're looking at. So the question reads here. So the question says, the cumulative frequency diagram below shows information about the distance d in kilometers that each of 120 students rather, walked to school each day. All right, so that's what we're dealing with right there, right? All right, so what we want to do is to understand that this is a cumulative frequency curve, and the information that we will get as it relates to the question will come through the curve and how we interpret this question as we go forward. All right, so let us look at the first question. So the first question is right here, right? So that's my first question. It says here, how many students walked at most 1 kilometer to school? So more than 1 kilometer to school. So it would be less than or equal to 1 kilometer. So in this question, what you want to do is to go where the kilometer is. As you could see, it's on the x-axis. All right, so it is down here on the x-axis, and that is where your focus is going to be for a moment before you switch. So here's the thing. We're going to take a line, right? So we're going to take this line, and we're going to take it up from the 1 kilometer, and we're going to take it to the curve, right? So we're not going to go through the curve. We're going to stop it on the curve, right? So we're going to stop it on the curve right there. So I could blow this up for us a little bit. So we could see that 1 kilometer right there. We take it until it touches the curve. And the moment it touches the curve, what we want to do is that we want to interpret how many students this 1 kilometer would have linked to on their y-axis. So we go across to the y-axis right there. All right, so there it is. So we're looking at interpreting this spot right here and really understanding what's going on. All right, so we want to take a good look at what's going on right there. Now we have to take into consideration as well the scale that we're dealing with. So if you really look at this, this would have been 10, and right here would have been 30, right? Based on what we have, 10, 20, 30, 40, 50, and it goes up like that. So what it means then is that we need to take some time quickly to understand what's going on for each of these little lines, that you see going up, all right? And when you look at it, you're counting by 2, right? So this line that comes across is at 36. So now in response to the question, right? So how many students at most would have walked 1 kilometer to school? So we're looking at numbers from 0 up to 36. So 36 or less. So we want to read off what's that number right here. So basically we could say 36. All right. So 36 students would have walked at most 1 kilometer to school. So that's the sort of interpretation that we want to have as it relates to these questions. So 36, right? So let me just pull this across quickly. And my response for number 1 would have been 36 students, right there. 36 students for that response. Now let's look at the next question. So the next question says, using the cumulative frequency diagram, determine an estimate of 1, the median. What the median is, it's your second quartile, Q2, and that refers to 50% of your sample. So the median All right, the median is actually what we'll call Q2. So, and Q2 refers to 50% because the median is actually that midway. All right, so 50% of your sample, so it's going to be 50% of the sample, and the sample is actually 120 students, and this is going to give me 60. But this is not the answer, right? This is not the answer. This is going to help me to understand where the answer is. So we're going to go where 60 students actually is. All right, so let's go back to the curve. So you'll take out a ruler and you're going to follow 60. And exactly where it touches the curve, you stop. Right where it touches the curve, 60. Right, so let's blow that up. I have a better visual right there. So right where it touches the curve, we're gonna take that line and take it down to the x-axis. Here it is. So I want to take this line down to the x-axis. And when I do take that line down to the x-axis, let me change the color to red. And so we can have a very good look at what we're dealing with right there. All right, so based on the scale that we're dealing with, now it's our responsibility to understand the scaling enough to know what number really comes off right there. Now look at the scale. We have a 1 here, then we have 1.5 here. So we actually have five decimal points there that we could work out what is 0.1, 0.2, 0.3. So quickly looking at this, 1.1, 1.2, this line is at 1.3. Let's check 1.4 all the way to 1.5. So this line is exactly at 1.3 kilometers right there. So that second response, our Q2, which is what we call the median, is 1.3 kilometers. So let's just respond to that where the question is, right? 1.3 kilometers. All right, so just gonna put that right there beside it. This is 1.3 kilometers. The follow-up question says, it's right here. It says the lower quartile. So we want to tell what the lower quartile is. Now the lower quartile is actually 25%. So the lower quartile, we call that Q1. It is actually 25% of the sample. And in this case, we're referring to 25% of 120. And when you work this out, 25% of 130 will give us, of 120 will give us 30 students in context of this question. All right. So we're going to go where 30 students is, and we're going to see if we could find that value. So again, 30. So you could see where 30 is. So I blow this up. So 30 students. And we take a ruler, take a line, and as it touches the curve, that's where you stop. Do not pass through the curve, right where it stops, where it touches it. I could blow this up a little bit more for us. And 30 coming across. So I could just write Q1 to show the line that I'm following. It's right here, Q1, and that's my lower quartile. And let's just take this line down to the x-axis to read off that value right there. So I'm coming down on that line. Let me put this line in red as well. All right, so you could follow that Q1 line and you'll see definitely that it comes down right here. This is the line. Now, what you want to focus on is, remember, we just picked up the scale here where two of those little lines will represent 0.1. So if you look, basically, this is like 0.5, this is 0.6, two more 0.7, two more 0.8, and this line is at 0.9, right? So definitely it's at 0.9. So it's 0.9 kilometers. That's our lower quartile. So we want to make note of that response. Our lower quartile is at 0.9 kilometers. The next question says, the interquartile range. Now, the interquartile range, if we're going to be dealing with the interquartile range, then we need to understand that there is a quick formula that deals with the interquartile range, right? So the interquartile range, and the word range there is talking about that Q3, which is the biggest quartile, minus Q1, which is the smallest quartile. So we have already found out what Q1 is, so we could write it down. So Q1 we found out to be 0.9. So we want to go and find what Q3 is. Q3 refers to 75% of the sample, right? So Q3, this is actually 75% of the sample. So we're talking about 75 over 100. You want to multiply that by 120, and you will find out that this will give us 90 students. This is not the answer. We have to use this to be interpreted through the cumulative frequency curve. So I'm going to go for 90, right? So let's go across. So let's blow our diagram up. We're going to go for 90. Let me see how big I could get my 90. All right, my 90 is right there. All right, I think that's big enough. 90 is right on top of 80 right there, because this would have been a 70. So what I want to do is I am going to take my ruler and take a line at 90, which is right here. And then I'm going to take this. The moment it touches the curve, that's where I'm going to stop. And then I want to take this line down and interpret this, the x-axis as well, right there. Right there. Right there. So we are right there. So I'm going to put Q3 on this up here. This is Q3. And the value for Q3 though, so we're going to have to zoom in on that spot right down there. So it came down, let me blow this up. It came down right in front of that 1.5. So it came down right there in front of 1.5. So let me just take off some of these markings. So you could see that it came down right in front of that. So it came down right there. Now remember, based on the scale, right? If you're really reading, right here is 1.6. So you're talking about a number halfway between 1.5 and 1.6, right? It actually came down at, I could write it here, like Q3 is actually 1.55. So it's like you're referring to 50 to 60, and between 50 and 60, you have 55. That's the sort of idea that you want to be thinking of. So it's 1.55, which is Q3 right there. It came down exactly halfway between 1.5 and 1.6. So let's go back here. So my Q3 has a value of 1.55. So definitely my interquartile range, as we said before, it's Q3 minus Q1, which is going to be 1.55 minus 0.9, a value of 0.65 kilometers. So that is the interquartile range, 0.65 kilometers. So let's put that on our answer sheet. So my interquartile range is 0.65 kilometers. And if you notice, my responses, I'm making sure that I have kilometers on where it should be. If I have students, I'm labeling my answers accurately and actually in the right idea concepts that we're dealing with here. All right. The C part of this question says, it says a student is chosen at random. So I'm reading part 3 here, which is the C part. So a student is chosen at random. What is the probability that the student walk for more than 1.5 kilometers? So we're going over 1.5 kilometers. It simply means then I'm going to be starting on my x-axis where the 1.5 kilometer is, and I'm going to just identify where does that touch the curve. So we need to go back to the curve, focus on 1.5. So 1.5, as you could see, is green this time. All right, so it's a little bit over 80. It looks like 82 to me. All right, so about 82. Let's go across. There it is. Yeah. All right, so it is 82 right there. All right, so it's a little bit over the 80 mark. So this is 82. But remember, though, we're talking about the probability chosen at random would work for more. So when we talk about more, we're going to go over that, right? When it's lower than that, we go beneath, but we're talking about over. So you reference, you want to go over that and all the way up to 120, right? So you want to know what's the difference between these two numbers, because you're talking about those over this, right? Because this is where the 1.5 is. So to find that response, what we're going to have to do is we're going to firstly, let me just take this off quickly. What we want to do quickly, all right? So what we want to do quickly is, all right, so we want to understand that this is 120 at most, and then we subtract that. So when you subtract the 82 from 120, you're left with 38, but that's not the answer. That's 38 students that would have walked for more than 1.5 kilometers. So then, as we say, it's a probability. So it's 38 out of the 120 students. So as a probability, we could have that. If you want to divide this by 2, you'll get 19 over 60. All right. So 38 over 120 is perfect. Or if you want to say 19 over 60, and that is also fine as a probability. All right. So we want to continue with the D part. So with the D part, it says here that, so if I should blow this part up quickly, it says complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. So we're still looking at that same question. We have our cumulative frequency curve there, and we want to complete the table. So firstly, there is a midpoint that needs to be completed right here, that midpoint. So it's the middle of that class that we have. So all we got to do is to add the 1.5 plus the 2. All right. So the 1.5 plus 2. So basically, I'm going to be adding 1.5. I'm going to add that to 2, and then I divide this by 2. And it's going to give me my mid value. All right. So 3.5 divided by 2, and that is 1.75. If you want to do it that way. If you are looking at the pattern, you could see a pattern 0.25, 0.75, 1.25, then it's 1.75, 2.25, 2.75. So if you look, there's a pattern, you could pick it up, or you could have calculated it easily. Now, the other part of this, it might pose a little bit of problem, just a little bit of problem, because when you're looking at this, what we have here is a frequency, F. F stands for frequency. And as you could see, we're going to be calculating the mean, which means that we're going to be working out fx here, f times x. So definitely with the cumulative frequency curve, that's a slightly little problem, because the values you get from the cumulative frequency curve is not your frequency. You actually get your cumulative frequency from your cumulative frequency curve. But whenever you subtract two consecutive cumulative frequency, then you will get the frequency. So that's what we're going to have to be zooming on to see what is the actual frequency here and the frequency here. We're going to have to pick up values. So I'm going to be picking up values from just a little above this. I'm going to pick up a value here, pick up a value there, pick up a value there. And then so you could see subtracting would have given us the frequency. So let's go again. If you get the cumulative frequency curve and you want the frequency, you have to find two consecutive cumulative frequency. In other words, then I am going to use 1.5 to find what's the cumulative frequency there. I'm going to find 2 to find what's the cumulative frequency there. I'm going to find 2.5 to find what's the cumulative frequency there. And I might just find 3 just to top off everything. So when we find those cumulative frequencies, we would see that when you subtract 2 consecutive cumulative frequency, you are actually getting the frequency. So it's a teaching learning process. So let me just guide us to it. So I might go from 1. Let me go from 1, right? So if I'm going where 1 is, right, and if you're working with me, here, all right, I'm going to have to just take the lines and bring it there. So if I go where 1 is, let me blow this up quickly. 1 is right here. So if I go where 1 is, right there, and let me highlight this, 1, what's the cumulative frequency? I'm gonna go across to pick up my cumulative frequency. All right. So 1 comes right there, and that cumulative frequency there. From previous questions, you could see that's a 36, right? So this is 36, but this is not the frequency. This is the cumulative frequency. So what I'm suggesting here is that we understand that 1, the cumulative frequency. Can I just put CF right here? So I'm putting some CF right here to bar off the thing. So at 1, I would have seen a 36, right? By that. So I was at 1. So at 1, I got 36. And 36 is not the frequency. It's the cumulative frequency. So you could see, we could see here. So there was a 12 here in the beginning, right? So you could see if you could subtract right now, if you could subtract the 12 from the 36, you could see how the 24 came about. The 36 and the 12, there are 2 consecutive cumulative frequencies. If you subtract them, then you will see where the 24 coming from, just leading you into it. So in other words, if I'm going to find the cumulative frequency here, all right, if I find this cumulative frequency here, then I could use it. I could use it along with the 36 to give me what 46 is. So let us see what the cumulative frequency at 1.5 is. 1, let me go up just a little bit above it. All right, there it is. All right, good. All right, so that's my 1.5, a little bit above 80, like 82, right? Well, I think we had this result anyway. So that's 82. So that's a 82 right there. So what I'm saying here is that that's a cumulative frequency at 1.5, 82. 82 right here. 82 right there. So then if you should subtract 36 from that 82, you would have seen where the 46 came from. Look, so we're talking about 82, and if you take the 36, you will see where the 46 came from. All right. So 2 consecutive, the difference between 2 consecutive cumulative frequency will give the frequency. So now that we know that, 82 will be used along with whatever frequency I get, cumulative frequency I get from 2 to give me that missing spot. So I'm going where 2 is. So I bring this up right here. I believe it's right there. All right. And then I'm going to go across with that. All right. All right. So going across right there. All right. So with that, I'm getting 112. This is 112. So then so basically then, we are saying that the cumulative frequency at 2 is 112. So the frequency now is to subtract. So we're going to have 112 minus 82. That is going to tell us that cumulative frequency right there, 30. So this is going to give, so let's go. 112 minus the 82 will give us 30. And that is the frequency that we're looking for. I only went through all of the others so that you could feel confident to see that this is how you will really find the frequency when you have the cumulative frequency curve. The next one, 2.5, we need to go where 2.5 is. So we're going to go where 2.5 is, take it up. 2.5, I think, sorry about that. .5 is here, pick it up, right there. Let's go across. All right. All right. So when we go across right there, that's 118. So we subtract. So this is 118 right here as a cumulative frequency curve. So 118 minus 112 will give us 6. So this is 6 right there. So we're definitely seeing that we have our frequency now. And the fact that we had the cumulative frequency curve, we went for the cumulative frequency and used that knowledge to understand that the difference between two consecutive cumulative frequency will give us the frequency. And that's what we use just to get the frequency. Why are we filling out? They asked us to fill out because we're going to do the mean, right? So right now what we have is this. So the mean, so we have the F and the X column. So we're just going to finish off this. For example, the 1.75, which is this right here, 1.75 times 30, that's going to give 52.5. So this is 52.5. Remember that this is the X column and this is the F column. So this is Fx, which is mean F times X. So 2.25 times 6, and that's 13.5. We're almost there. The mean X bar is the sum of the Fx column divided by the F. All right, so we're going to be adding up everything here. So we're talking about 3 plus 18 plus 57.5 plus 52.5 plus 13.5 plus 5.5, 150. All right, so this gives us 150, and we want to divide that by 120. So the answer is 1.25, and that's the mean. All right, so that mean is 1.25. Thank you for watching Delemat's Concepts, and see you next time for more stuff.